Welcome to Understand the Math. This video is part of a series of videos on linear algebra and its applications and covers section 2.2, part 1, on the inverse of a 2x2 matrix. I'll walk through example problems to show you how to calculate the inverse of a 2x2 matrix and then walk through an example of using the inverse of a 2x2 matrix to solve a linear system of equations. Be sure to check out the link below for free guided notes that you can highlight and fill in as you watch this video. The inverse of a matrix, written as A inverse, is a matrix such that when it is multiplied by A, results in the identity matrix. When we multiply A inverse on the left by A, or A inverse on the right by A, we get the identity matrix. Just as a reminder, the identity matrix is this matrix when A is a 2x2 matrix. Because A inverse needs to be multiplied on the left and on the right by A, only a square matrix can have an inverse because the sizes of A and A inverse need to match up when they're multiplied together. When working with inverses, we classify matrices as either being non-singular or singular. A non-singular matrix is a matrix that has an inverse and is invertible. A singular matrix is a matrix that does not have an inverse and is not invertible. Inverses of matrices are used in many different ways. They're used for solving systems of linear equations, where the solution x can be written as A inverse times B. They're used for finding inverse linear transformations, where an inverse linear transformation can be written as A inverse times x. And they're used in finding solutions to lots of application problems. Let's now talk about the formula for the inverse of a 2x2 matrix and walk through some example problems. For a matrix A that's equal to A, B, C, D, the inverse of A is equal to 1 divided by AD minus BC. That's the main diagonal elements multiplied minus the off-diagonal elements multiplied. And that gets multiplied by a matrix that contains D and A. Notice that those are the diagonal elements switched. And then it contains elements minus B and minus C. Those are the off-diagonal elements in the same place, but with a negative sign added to them. The quantity AD minus BC is called the determinant of matrix A. It's written as DET of A, and it's AD minus BC, and it's really important to realize that this is equal to a number. Any matrix A will have an inverse if the determinant of A is not equal to 0, because we can't have 0 in the denominator. Let's now walk through our example problems. We're going to determine if the following matrices are invertible, and if they are, we're going to find their inverse. The inverse of a matrix will exist if the determinant of A, which is given by AD minus BC, is not equal to 0. So let's calculate that. In our problem, the determinant of A is equal to 8 times 2, that gives us 16, minus 3 times 4, which is 12, so our determinant is equal to 4, and that is not equal to 0. So that means that A is invertible, and we call A non-singular. Let's now calculate A inverse. A inverse is equal to 1 divided by the determinant of A, which we found to be 4. And then in the matrix, we're going to switch the diagonal elements, and the off-diagonal elements get a negative. Let's now bring the 4 inside and divide every entry by 4, and we get a 1/2, a minus 3/4, a minus 1, and a 2. And this matrix is then A inverse. Linear algebra has a lot of nice built-in checks in it. The built-in check for determining if A inverse is correct is to take A inverse and multiply it by A. Let's go ahead and do that. We have 1/2 minus 3/4 minus 1 and 2, and we multiply that by our matrix A, 8, 3, 4, 2. When we do the multiplication, we end up with a 4 minus 3, which is 1, a 3 halves minus 3 halves, which is 0, an 8 minus 8, which is 0, and then a minus 3 plus 4, which is a 1. And we can verify that this is the identity, and we know that our answer then is correct. Let's look at our second example. We're again going to start by calculating the determinant of A. That's going to equal minus 1 times minus 6, which is 6, minus 2 times 3, which is equal to 6, and that gives us a value of 0. Because the determinant of A is equal to 0, A is not going to have an inverse. So we'll say that A is not invertible. And A is called singular. Let's now see how we can use inverses to solve linear systems of equations. We're given a linear system of equations written in matrix vector form, and we're going to assume that A is an invertible matrix. To solve for x, we're going to multiply this equation on the left by A inverse and on the right by A inverse. A inverse times A times x is then the identity matrix times x, and our right-hand side is A inverse times B. This gives us a formula for our solution x, and its x is equal to A inverse times B. There are 3 steps that we can follow for using an inverse matrix to solve AX is equal to B. The first step is that we need to find A from the linear system of equations. The second step is to find A inverse using the formula that we just went over on the previous page. And then the third step is to find X using the formula X is equal to A inverse times B. Let's see how all this works by walking through an example. We're going to use a matrix inverse to solve the following linear system. Using the steps outlined above, we'll first find matrix A. Let's write our linear system as A times xy is equal to our right-hand side, which is 3, 0. Let's now fill in what A is. We have our matrix A, we have our xy, and then we have our right-hand side. The numbers that we're going to put into A are 1, 3, 2, and 5. Let's label our matrix A and also highlight it. Our second step is to find A inverse. So A inverse is equal to 1 divided by the determinant. That's going to be our main diagonal multiplied minus our off diagonal. So that's going to be 5 minus 6. And then the entries inside the matrix are going to be the main diagonal elements switched and a negative added to the off diagonal elements. Since 1 divided by 5 minus 6 is negative 1, each entry now is going to get multiplied by a negative. This matrix is our A inverse. Our third step is to use the formula X is equal to A inverse B to find our solution X. This gives us X is equal to A inverse, which we just found. That's minus 5, 3, 2, minus 1, times B. That's our right-hand side up above. That's going to be 3, 0. And then we just do the multiplication. We get a minus 15 plus 0 on the first row, and then a 6 plus 0 on the second row. So this gives us an answer for our solution X, minus 15, 6. Since our original linear system was written in terms of X and Y, we'll write our solution also in terms of X and Y, and we'll say that X is equal to minus 15, and Y is equal to 6. Be sure to check out the next video in this series where you'll learn all about elementary matrices and computing the inverse of a 3x3 matrix.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.